So let's have a look at these indices here. What do they actually mean? Well, a to the 2 is just a shorthand way of writing a times a. And a to the 3 is just a shorthand way of writing a times a times a. Right? So how many a's do we have on the top here? A times a times a times a times a. Remember, this is a times here as well. That's really important. If this was a plus, everything would be different, right? Okay, but it's all timesing here. Okay, so a to the 2 is a times a to the 3 is a times a times a. If we multiply them all together, that would be 1, 2, 3, 4, 5. So a times a times a times a times a. Or another way of thinking about it is 2 plus 3. So a to the 2 times a to the 3, it's really easy to work out. Let's write it up here. A to the 2 times a to the 3 is just these green a's here. You add the exponents together because that's what they mean. How many a's were multiplied together. So that actually equals a to the 2 plus 3 equals a to the 5. That's really useful. And in some ways you may think, oh, these exponents make maths a bit more complicated, but their purpose is to make it less complicated, as long as you remember what they actually mean. Very similar to up here, if you think about expanding everything out, it becomes clearer. A to the 2 is a times a to the 3 is a times a. If we multiplied those two together, you'd just be adding up all the a's, the number of a's that you're multiplying together, not actually adding them up, but counting how many there were. And so the beauty of this exponent mathematics, this index laws, is that we can very easily multiply things together by simply adding their indices or exponents. That's really useful. And above the dividing line here, they add. Below the dividing line, well, they subtract. So let's think about the b's now, okay? We had a look at the a's. Let's think about the b's. Okay, so this is b times b to the 2. That's b to the 3, isn't it? Okay, so let's just write that over here. b times b to the 2 is b to the 1 plus 2, which is equal to b to the 3. Okay? And there's a b to the 2 underneath. So let's put a b to the 2 underneath here and a b to the 2 underneath here. We've just carried over, just focusing on the b's right now. So if on the top of the dividing line we can add our indices, underneath the dividing line we can subtract. So b to the 3 divided by b to the 2 is exactly the same as saying, so this, all of this here is the same as b to the 3 minus 2. Does that make sense? What's 3 minus 2? B to the 1. What's b to the 1? Well, that's just b. So that's just b. Does that make sense? Let's write it all out. Okay, so this is b. This is times b, and we had, this is b times b here. And we can just cancel those out, that b with that b, that b with that b, that leaves just b. So our answer is correct here. But the indices make the maths actually really easy. So let's go back to our initial problem, tidy all this up here. And what we're going to do is do it the smart way this time. we're just going to add and subtract our indices, our exponents, our powers, whatever you like to call them, top and bottom. So we could think about that's a plus 2, and this one is a minus 1, because it's like an a to the minus 1. That's what 1 on a actually is. And this is a b to the minus 2. We can't actually write it like that because the fact that it's below the dividing line actually means that it is a minus 2 here. So let me just rewrite this so that it's very clear. Okay, so this is actually a to the 2 times b to the 2. We already know that's b to the 3, but let's just leave it like that for now. And then, let's see, what have we got? A to the 2, b to the 2 times a to the 3. Okay, now all of these indices underneath are going to be negative numbers. So this is dividing by b to the 2 is the same as timesing by b to the minus 2. And dividing by a is the same as timesing by a to the minus 1. So suddenly our multiplication has become simpler because all we need to do is add up the indices. This is a really useful tool to simplify maths. So now we can just add up all of these indices in like terms. Let's do all the a's first. Okay, so this is a, set up a bracket here, 2 plus 3 minus 1. 2 plus 3 minus 1. And then let's do the b's. Okay, set up brackets here again. 1 plus 2 minus 2. Okay, 1 plus 2 minus 2. And you can see this will become very simple straight away. 2 plus 3 minus 1, 5. So that's a to the 4 times b, 1 plus 2 minus, oh, that's easy. That's just b to the 1, which is b. Okay, so the answer is a to the 4 times b. And we can go back and check our working out. Let's see, let's do that here. A to 5 minus 1, a to the 4, b 3, b to the 3 minus 2. Yeah, times 2. That's right. So this is our answer here. So the indices, if we understand that the indices on the top above the dividing line are positive numbers, and the indices below the dividing line are kind of negative numbers. Maybe you haven't seen this before, but it kind of makes sense, and that's exactly what's intended. So using indices allows us to turn multiplication operations into pluses and minuses, which is so cool. Okay, so let's go back here again. So we have 15 times u to the 2 plus 10 times u. Now there's a couple of things that we can do here. We can factorize the 15 and the 10, yeah, but we can also factorize the two terms with the variable u in it. So what we're going to do is think about it this way. We're going to set up brackets. We're going to have a plus here in the middle. And then we're going to have something here, and something here. Let's do the numbers first, the 15 and the 10. Okay, so we're looking for the largest number that we can divide into both of these and still retain a whole number. And I think that wouldn't be 10, it's probably 5. How you arrive at that number is a little bit of trial and error, but you're basically trying to reduce things to prime numbers. So 5 into 10 would be 2, yeah? So let's write the 2 there. 5 into 10 is 2. 5 into 15 is 3, so there'll be a 3 here. What number did we bring out? It was 5. Let's check our maths. 5 times 3 is 15, 5 times 2 is 10. and the plus sign is preserved. So that's okay. So that takes care of the numbers. Now let's do the variable u. So what can we do here? Well, we divide again, and all we can really do is divide this by u. That will make that a 1. So 2 times 1. And we know that we don't really need to write that, but let's just leave it there for now. And then this u to the 2 divided by u, that's a u. And what did we bring out here? We brought a u. Let's check our maths. Okay, so u times u is u to the 2. That's okay. U times 1 is u. So that works. So we've checked our numbers, we've checked our variables u, and the last thing we can do is just tidy up. So this times 1 here we don't need, but the reason we put that there was so that we could check our work, right? And then we just take away these little green lines here. So let's just do a final check. 5u times 3u is 15u squared. Perfect. 5u times 2 is 10u, and our plus is preserved there. And that's how we factorize that expression, but we're also using our knowledge of our index laws. Great.